Welcome to 365 Math. I know quite a number of you have difficulties solving mensuration problems, but in this example here, I'm going to show you how you can solve this question. It is a question that falls under chords and segments. The question says, an equilateral triangle is inscribed in a circle of radius 10 centimeters. Find part A, the area of the triangle, and part B, the area shaded. And we are going to go ahead and start with part A of finding the area of the triangle. So the term equilateral means that the sides of the triangle are equal. When you look at this diagram that we have, it means this side and this side and this side, they are all equal, and each angle within this triangle is equal to 60 degrees because the angles in a triangle add up to 180 degrees. So that is 60 degrees, and this also becomes 60 degrees. Having this, then we can further illustrate something here. If we have this center as O, and I'll name this B, this is A, and this is C, we can get OA, OB, and OC. But already we know that OA is equal to OB, which is also equal to OC, and this is equal to 10 centimeters because they are the radius. So if we take point OA, which is this point, and then OC is this point, that's the radius, and also OB, that is the radius. Now, if we look at this, we have got three angles that we have at the center. That's angle 1, angle 2, and lastly, angle 3. And these three angles add up to 360. And because they are equal, they are going to be each 120 degrees. So we have 120 degrees for AOC as well, 120 degrees. Now that we have our diagram like this, we can then move ahead and find the area of the triangle ABC. And we're going to look at it in this way. The area of the triangle ABC is equal to the area of the triangle AOB plus the area of the triangle BOC, and lastly the area of the triangle AOC. And I will show you these triangles that we're talking about. So we're saying the area of this triangle right here, ABC, is equal to the area of triangle AOB, this triangle, plus this triangle AOC, plus the last triangle BOC. So that is how we're going to find the area of the triangle ABC. Now, since these triangles, they are the same, we're just going to find the area of one triangle, and then we'll multiply it by 3 since there are 3 triangles, taking the area of triangle AOB, which is equal to half AB sine theta, which is equal to half. Now AB, this is the line that we're looking at, AB. So AB is equal to OA plus OB. So we're going to rewrite it as half times OA multiplied by OB sine, and our theta is sine AOB, like this. So now punching in the values, we have half multiplied by 10 times 10 sine 120, which gives us 25 root 3. That is the answer. But since there are 3 triangles, we are going to multiply this 25 root 3 by 3, and we get our answer as 75 root 3. And putting it in decimal form, this is equal to 129.9 square centimeters. This is the area of the triangle ABC. We want to find the area of the shaded region. So this is the shaded region. Everywhere that we have a blue color, that is the shaded region. And to find the area of the shaded region, we are going to say the area of the circle minus the area of the triangle is equal to the area of the shaded region. So writing this, we have area shaded is equal to the area of the circle, or just write it as that, minus the area of the triangle ABC, which we just calculated. Now, to find the area of the circle, the formula is pi r squared. So punching this with pi, our radius is 10 centimeters. So that is 10 squared. All this minus 75 root 3. And the reason why I'm using 75 root 3 is that I want to get a more exact answer rather than a rounded off figure. So if we then multiply pi times 10 squared and we subtract 75 root 3, we get our answer as 184.26 square centimeters, which if we round off to one decimal place, we get our answer as 184.3 square centimeters. So there you have it, guys. This is how you solve this problem. I hope you learned something. Thanks for watching. Please do hit the subscribe button for more videos. See you in the next one.